In order to understand how an electronically controlled shock absorber works, an understanding of the operation of a conventional shock absorber is required. Let's see a simplified animation of how a basic shock absorber works. A shock absorber is basically a hollow tube filled with hydraulic fluid or oil. A piston attached to a piston rod moves through the oil in the tube. The piston has openings or orifices that the hydraulic fluid is forced through as the piston travels up and down in the tube. The orifices only let a small amount of fluid through the piston at one time. This slows down the piston movement, which in turn slows down the movement of the spring and suspension attached to the shock absorber. The amount of resistance that a shock absorber provides depends on the size of the openings in the piston, the viscosity or thickness of the hydraulic fluid, and the speed at which the suspension tries to move it. A shock absorber will provide more resistance as the size of the openings in the piston are decreased, because less hydraulic fluid is allowed to travel through the piston in a given time. Increasing the viscosity or thickness of the hydraulic fluid also reduces the amount of fluid travel through the openings and increases the resistance of the shock absorber. All shock absorbers are velocity sensitive. The larger the bump, or the faster the vehicle is traveling, the faster the piston will try to move in the tube, and the more resistance the shock absorber will provide.